Here is a request from one of our subscribers who wants to understand concepts about combination of function and function of function. We'll take up f of x equals to 2x squared and g of x equals to 3x plus 1 as two different functions with their combinations and compositions. We'll also understand what is the difference between the two, composition and combination. I'm Anil Kumar. Welcome to your YouTube channel where your questions and our suggestions meet. A learning platform absolutely free for the last 15 years. Here is a wonderful question which can be part of IBHL final test paper. The question is provided by one of our subscribers. We are given a function f of x equals to 2x squared and g of x equals to 3x plus 1. We need to find all this. So it's a combination of a quadratic and a linear function. So when you combine them, you get what? You get a quadratic function, right? So that's what we will see now, doing one part of the after the other. So A, let's see what is f of x plus g of x equals to. F of x is equal to 2x squared. So we can write 2x squared plus g of x is 3x plus 1. So the combination is basically a quadratic equation. So you just put them together and add them up. Well, in this case, you can actually factor them also. 2 times 1 is 2, the product, and the sum of 3. So we could actually write it in factored form also, splitting 3x as 2x plus 1, and then combining 2x, we get x plus 1, right, plus x plus 1. And you could put this in brackets, x plus 1 being common, we get 2x plus 1 in the factored form for the same thing. So that is how you could do part A. It is not necessary to write this form. Even that statement, standard form, may work. Correct. Now let's look into the second part, which is we need to now find what is f of x minus g of x. So that gives you 2x squared. So these are called combinations. X belongs to real numbers, that is what we are assuming, and the functions, if they are on the common domain, they can always be combined. So g of x is 3x plus 1, so we'll do minus of 3x plus 1, and that gives you 2x squared minus 3x minus 1. Now in this case, sum and product minus 2 we need, and so to get minus 2, what should we do? When you multiply, you get a negative number times a positive number. Correct. But now this cannot be easily factored, so we'll leave it like this. Great. The next part over here is to find f of g of x. Now that is composition of function. So what we did so far was combination, right? And now what we are going to do is composition. One function as inside the other function. Do you see that? That is the composition. So basically, is f of what is g of x? G of x is 3x plus 1, right? So now f of x is 2x squared. So x will be replaced by 3x plus 1. So it'll be 2 times 3x plus 1 whole square. You can always expand 3x plus 1, and what you get is a square plus 2ab plus b squared. You can write this as 9x squared plus 2ab means 6x plus 1 square, which is 1. And you can also open this bracket and write this as 18x squared plus 12x plus 2. So that becomes the composition of function f of g of x. So I hope so far everything is absolutely clear. Well, you can always subscribe to my videos and write comments. Now, let's look into. So let's begin with part D, which is f of x whole square. Now, in reading this, there can be interpretation problem. So what I've done here is I've also given you part F, where we have written within the bracket x squared. So there is a difference between this, which we are treating this as f of x and everything squared. You understand the significant difference here, correct? So it is not that x has been squared. We will do that part in part F, right? So let's see how do we answer this question. So we'll rewrite this as f of x whole square. F of x is 2x squared. And square this, right? So becomes 4x to the power of 4. Is that clear to you? That is how we are going to do part E, correct? Now let's take part E. E is f of g of a plus 1. So the argument for g is a plus 1. We are going to replace x in g of x with a plus 1 to move forward. So it becomes f of 3 times a plus 1 plus 1. Is that clear to you? Open and simplify. So we get f of 3a plus 3 plus 1. Right. So that gives you f of 3a plus 4. Now we are going to replace in f of x the x value with 3a plus 4. And we get what? We get 2 times x is now 3a plus 4 whole square. So this can be expanded using the formula a plus b whole square. So we get 3a whole square, a square, plus times 2ab means 2 times 3a times 4 plus 4 square. Everything twice, right? So we get 2 times 9a square plus 8 times 324a plus 16. When you multiply each term by 2, you get your final answer, which is 18a square plus 48a plus 32. Is that clear to you? So that is how you're going to do part E. And now let's move on to part F. I hope all the steps are absolutely clear. Perfect. So the last question from this series, F, which is f of x squared plus 1. So basically, we are going to replace the argument x with x squared plus 1. So you get this as 2 times x squared plus 1 whole square. Perfect. Now you can square this. 2 times a square. So we are using this formula once again. Let me write down the formula. A plus b whole square is a square plus 2ab plus b square. Correct? So we get x to the power of 4 plus twice x square plus 1 square is 1. Now open this up and write the final answer, which is 2x to the power of 4 plus 4x square plus 2. Right? So that is going to be the solution for F. So I hope all the steps are absolutely clear. That is how we work with composite functions and combination of functions. The first two examples were of combination of functions, and the next examples were composite functions, right? So I hope it is absolutely clear. Feel free to write a comment, share your views. If you like and subscribe to my videos, that'd be great. Thanks for your valuable time and all the best.